Okay, so we're doing 6-3 medians and altitudes of triangles. Just to review, a median looks like this. It goes from the corner of the triangle to the midpoint of the other side. It doesn't necessarily bisect that angle, it just bisects the side. And then for altitude, altitude is the height of a triangle, it's perpendicular, and it just goes from the top to the bottom straight down with a 90-degree angle right there. So when I define them, that's what I'm defining over here. So median of a triangle is a segment from vertex to midpoint of opposite side. And just like a little picture down here. Here's a vertex. Let's say this is the midpoint. Just be a line here. Then it breaks this into equal pieces, and then I will continue highlighting whatever we're talking about in orange. That's the median. And then centroid, of course, that is a new word, but at this point you might be able to predict that a centroid is where the medians intersect. So where 3 medians intersect. And that's called the centroid. And then we have altitude of a triangle. By definition, it's the perpendicular segment from vertex to opposite side, and abbreviating opposite. And it looks like this. And with an altitude, there aren't specific measurements involved. Like, it's not bisecting the side, it's not bisecting the angle. And then orthocenter is where the altitudes intersect, where 3 altitudes intersect. Okay, so we're going to flip this over to the back of the notes. Just here, just the back of the note page. Okay, so 6-3 continued. We do have one theorem, and it's called the centroid theorem. With a centroid is where the medians intersect, so I'm just going to highlight the medians here. These are the medians. Again, the medians of ABC meet at point P. So where they meet is right here, and this is the centroid.
How do you know they're medians?
They go from one vertex to the midpoint of the other side, and I know this is the midpoint because this is the same length as this, and so on and so forth. Why is it so blurry? Okay. So with the medians, there are specific measurements here. It says that AP, so it's talking about this right here, is 2/3 of the whole segment. Anytime like fractions are mentioned, it gets a little bit confusing, so I'm going to try to explain it without fractions and then bring the fractions in. This segment right here, we're going to specifically focus on this one, but this applies to all of the medians. So we have our centroid right here. This segment right here, this is like one part, and this is 2. So there's 3 parts total. This is 1 part, and then there's 2 parts over here. So for example, like using numbers, let's say this was 5 units, then this would be 10. It's double. Or if we were told that AE is 15, like the whole segment is 15, you could take 15 divided by 3 to get each part. Like this would be 5, and then this would be 2 parts, which would be 10. And we'll do some practice problems with that too. Okay, and then the other thing I want to mention, and some of you may have already noticed this chart right here is a concept summary of all the vocabulary we've learned like the last few lessons. So here it says perpendicular bisector, and the perpendicular bisectors intersect at the circumcenter. It shows a picture, and it gives like an explanation with an example. So you could use this chart if needed now that we've learned them all. So angle bisectors intersect at the incenter, medians intersect at the centroid, and then altitudes intersect at the orthocenter. Now, as far as the dimensions of an altitude, the dimensions aren't, like, there's no calculation, or it's not like the others. All you have to know for altitude and orthocenter is that the altitudes intersect at the orthocenter. That's all you have to know for that. Okay, we're going to go look at the examples on the practice page.